Good morning, everyone, and welcome to Webinar Wednesdays with Wales Darby. I'm John Resso, Rob Clemens here, and we're going to take and just have the conversation about best practice install for Fujitsu. This is, this is not out of Fujitsu's manuals. This is just what we've experienced, whether we're in the field or working with contractors. So please feel free to jump into the conversation on the right-hand side of your screen. You'll be able to go in there and send us questions, or if you want to participate, just blast it out there. Rick Coster, Jim DePalma are here in the background. Rick's got like 19 computers in front of him and headsets and mouse and all kinds of stuff going on, but looks pretty crazy what he's doing there. So good morning, welcome, and thank you, and we'll jump right into it. So we're going to go through today basically best practice install of a mini split, Fujitsu mini split, right? We're the Fujitsu guys. We got a Fujitsu unit behind us. So we'll go through it. So everybody works a little different. So just work with us here as we talk about how a job happens. So a job is sold, whether you're a one-man show and you take care of everything, or whether you have a sales force, they sell it, and then you're the installer. You know, something happens, a unit is sold. And you're going to get the equipment, you're going to get out to a job site. And when you get to that job site, usually, Rob and I were talking about this yesterday, you know, we get there, we want to walk the job site, right?
Yeah, so basically, first thing you want to do, take a look around, notice indoor unit clearances and stuff like that, as far as the equipment is concerned, where we're going to be doing the installation, other things that we want to look for when we're going to be putting the outdoor unit in, any kind of obstructions that might be on the outside of the building or the home, such as dryer vents, sprinklers, gas meters could be located at the outdoor unit, somewhere around the outdoor unit as well. So as far as coding and stuff like that is concerned, we want to make sure that we follow all that as well. So
not next to the sewer drain outside,
right,
sewer vent, you know, anything along them lines. Yeah. Anyway, we won't go there. I mean, it's also important to know how you're going to run your electric. Usually, run the electric from the panel to outside to the outdoor unit. That's usually a concern. So understanding where your indoors are, where your outdoors are going to be. A lot of this has to do with, all the things Rob mentioned. In addition to that, we have minimum line set distances and maximum line set distances. You hear us talk about that a few times throughout the webinar, but we want to make sure we adhere to them. So sometimes on a one-to-one system, this is a one-to-one system, right? We want to make sure we hit our minimums, whether it's 9, 10 feet, whatever that number is. We may have to move that outdoor unit a little bit to the left or a little bit to the right to achieve those minimum line set distances. And all the line set distances, just to clarify, it's been a few years where, we go through that book and kind of get everybody up to speed. It's always flare nut outdoor to flare nut indoor one way. That's your minimum line set distance. So whether that's a 9 or a 10-foot number, whatever it might be. So hopefully, if you do have a sales force with you that sold the job, hopefully they're going to the job with you, and you're going to do a walkthrough and kind of get an understanding, and then you're going to give them your input as to what's going to make the install better. And then sales guy leaves, and now you're ready to start unpacking the equipment. And when we start unpacking the equipment, it's always important to know what you're installing. Okay, on some of our 24,000 BTU heads, they're going to come with a little adapter. The little adapter is packed with the head. And we always get phone calls, oh, I didn't get the adapter. Or you're taking the outdoor unit apart and you start to throw away all the styrofoam, but in that styrofoam there were reducing fittings for the A port, and that got thrown away. So always just take your time unpacking, make sure you see what comes with the equipment. We have remotes that are, thrown out with the box. So just all that stuff comes with it. If it's a 3-wire or if it's a wall unit, the remote's going to come with it. On a lot of the new Fujitsu equipment, if it's a 2-wire system, you have to purchase the wall controller separately. So just a heads up there, we've been getting a few phone calls about, you know, controllers and what wall controllers do I use with this type of head. You know, your compact cassettes, your ARUs, they used to come with a controller. That's no longer happening. It's a la carte. Fujitsu listened to some feedback where guys wanted a better controller and they didn't want to have to buy another controller on top of getting the one with the unit. So now it's a la carte. So just keep that in mind when you're out there selling these jobs. What do you got to add to that, Rob? We kind of did the unpacking, and this is where we're at.
So basically, the main focus is to make sure that you have a plan before you actually get in, start the work, and then as you go through, you'll get more and more accustomed to the way, you know, you and your installers, you know, work and how you get the job accomplished, and having that plan kind of leads into that.
Good. So our suggestion is, you know, get all the equipment unpacked, put it where it's going to be installed, and that'll make your life a little easier. And then we always recommend starting inside the house first. And the main reason for starting inside the house with the indoor heads is you're clean, right? It's first thing in the morning, you're clean, your feet are clean. Who knows? Could be a rainy day, ground's muddy outside. We want to try to you know, keep everything inside the home as clean as we possibly can. So indoor heads, I know aesthetically we always like to center things and you know, make it look really good on that wall, but think about a mini split and how a mini split works. If I'm installing this wall unit right here, the temperature is going to be sensed at the indoor head, right? On our return air coming down across, and then it'll get to the coil, and then we'll blow, I'll stay on the cold side, we'll blow the cold air out of the unit. So yes, it would probably look better in the middle of the room and centered on that wall. But if I have a wall here that has a door, a windows, and you know, that's like my exposed wall, I may want to consider putting it more on the towards that outside wall and letting it blow an air curtain across that outside wall instead of centering it in that room. That way, as this air, the cold air infiltrates through the windows, through the wall, through the door, somebody goes in and out of the door, this unit will see that temperature change and it will react to that temperature change and just keep a more common temperature in that space and just keep you more comfortable. So keep that in mind. If you're unsure of what I'm trying to say here, just, you know, email Rick or send Rick a question. We can always get back to you and go through some design type features. We do a bunch of training on that. So I don't want to bog this down going into that, but that's kind of where we go. So let's say I went through the house, I picked all the spots, I got the right locations, I got the unit sitting there on the floor. Where am I going next?
Well, before we get to that, I just want to add something else. There's some other things you want to take into consideration as well when mounting your indoor units, especially the wall mount units. Is there any kind of obstruction directly in the way of the unit, drop header? Maybe it's a very short wall that you are mounting the unit.
6 feet, right?
Yeah,
Usually
right.
6 feet as well.
Yeah, because in low fan speed, the equipment will throw the air 9 feet straight forward and cooling. So we want to make sure that we're not going to be deflecting air back to the equipment and causing short cycling, because eventually that leads to water running down the interior walls and unhappy customers. So take those things into consideration as well. I've even seen air getting deflected off of ceiling fans as well, causing, you know, those same kind of issues. So.
Right. Proper clearances, right? We got a minimum distance to the top. We got a minimum distance to the left side, minimum distance to the right side. Remember, the controllers are on the right side of these, so you're probably going to want to leave a little more space there. Rob hit the airflow clearances, so that's all good. So next, we got our spot pick, right?
Yeah, so we have our location. We have our mounting bracket. Now, this mounting bracket is specific to our wall-mounted units. The most common units that we sell is the wall-mounted units, or are the wall-mounted units. A couple things about the plate itself. You can see there's a number of holes all around. One thing that we want to make sure is that we try to get this into at least 1 or preferably 2 studs. They give you ample amount of room here. Most of the time we're dealing with 16 inches on center. So once we find a beam, we can always, go 16 inches from there, hopefully find another beam. If not, we can, we can always find that second beam. A couple other locations on the plate that are very important towards the system. We want to make sure that we are covering all the pressure points. So where the wall mount unit is actually going to be putting weight on the bracket itself. So top corners, that's where the unit is actually resting on as far as the top of the unit is concerned. So we want to make sure that we have some sort of anchor if it's not in a stud up at the top. Have like a 30-pound test anchor drilled into the wall and screw these top corners in. Another connection point you can take a look at down here. This is where the bottom of the unit clips in. So once we're done making all of our connections, we close the unit in. You hear those two clicks. That's these two openings right here. So we want to make sure that we're putting another screw right above each of those holes. So you can see right there the holes. Okay, here's our little holes where we're going to put our screws through. So once again, we want to get 30-pound test anchors in there and make sure that this bracket is completely secured to the wall. If you are trying to get this unit dead center, one thing you're going to want to take notice to is the top hole right here, which is really meant to, just let the bracket sit on the wall so you can mark it out and make sure everything is all level. That's not actually going to be center of the unit. That's center of this mount. You can actually see there, I don't know if you're going to be able to see it here, but there's going to be a little line and it's going to say unit center right next to it. So if that's something that you're looking to do, you can go right to that point as well. That'll be your center point.
Put a little level right here. This is where you're going to set your level to make sure that your bracket is level. So on the back of a wall mount unit, your line from the unit runs along the back. So it starts on the right side of it and it goes about to the center. Some guys will leave it behind there and they'll bring the line set in from the right-hand side. Some guys will take and pull it out and they'll exit through the well, let's look at the unit. Right. So let's call it left-hand side, right-hand side. So they'll exit through the right. That means they're taking that wire, or the copper, they're going to bend it out, they're going to stick it out through the wall to the outside and make their connection points outside. So a couple of different ways that you can do it. And we're not dictating which way you do it, it's whatever way works for that application, because sometimes the application dictates how you have to do it. So you're going to take and end up drilling a hole right here. So most of the time what we would recommend is that you're going to take a, maybe an 1/8 inch feeler bit. You're going to center it up. You got arrows here. You can draw 2 lines, one here, and that'll give you the center point of your hole. Okay, down from here, across from here, that's going to give you the center point of your hole. So you could take that feeler bit and you're going to drill to the outside. And when you drill outside, you drill a little bit on a downhill angle, because we want to make sure when we run our line set through there and we have our condensate drain going through there, it's going to go to a negative drain. So we just want a little bit of a pitch, nothing crazy, just enough to make the water flow. It's critical that you understand where that hole goes. Once you figure out, inside, outside, yes, I'm good. Then you're going to take your hole saw, 2.5 inch hole saw, and you're going to want to, keep it inside of your framework here. Sometimes we'll see these, you got a little smile left underneath where the guy cut too low and hung the bracket too high, or you'll have a little smile face over here where they cut too far to the right. So use these arrows, draw your lines, make your life easy. One hole, done. So you'll drill them out, and then we get into a couple of different methods of connecting, which we'll talk about shortly. This is the most common, okay? So that's why we have this in front of us. We have ceiling mount units. We have floor mount units, right? We have small ducted units. We have medium static ducted units. We have high static ducted units. We have multi-position air handlers. So depending on what type of indoor head you're using on any type application, there are different mounting methods for that unit, and all that material will come with that information. We're not going to sit here and break down each one, but if you're got a ceiling cassette, you know, it's going to line up. It's basically going to fit in a typical drop ceiling. It go into that 2x2 square with the ceiling cassettes. Again, the remote is going to be separate, and the grill is going to be ordered separately, just so you get to the job site, you know, you got everything you need. That'll be hung with threaded rod, right? That has a built-in condensate pump. So knowing the item that you're installing, you know, you really have to understand, do I have a condensate pump? Do I need a condensate pump? Okay, here we have a Freezy condensate pump on the bottom of this unit because we're unable to drain to, you know, negative drain here. So we added the condensate pump to this unit. Most wall units don't get condensate pumps. So understand the appliance that you're installing and know the needs of that appliance to make sure you have all the material on the job site when you get there.
We got a question from Tim. He's asking about the plate and the unit itself. From Robert, people point out, how far does the actual unit extend past the plate?
Yeah, so the unit itself is going to be, what is it, 2 inches from the end?
Just about.
Yeah, roughly.
Just about.
Yeah, so right around 2 inches from the end of each side is going to be your, you know, your total unit length.
Good question.
Yeah, so one other thing I wanted to go over really quick. So John went over the 2 different ways that we can go out behind the unit. There's also a couple of ways that we can install the unit where the copper doesn't necessarily go out at the back. So let's say we're going out over a window or something, and we need to get past that window before we can get the copper outside because there's some sort of header that we can't drill through, you know, right above that window. There's also little knockouts on the left and the right side, and also on the bottom side that you can bring the copper tubing, the condensate, and the wiring through. And in those applications, if you want to make it a nice finished look, you could use some sort of line hide on the inside of the building as well.
Yep, great point.
So
That's good.
Yep.
Good. So yeah. So you know that's kind of wraps up, you know, what goes on here. Now it gets to connecting methods, and there's a ton of different connecting methods, right? If I mount the bracket on the wall, I'll hinge the bottom of this unit open. I'll take some of the styrofoam that came with the unit, and I'll put it under the corners. And let's say I'm coming in from the left side, and I'm going to leave the line behind the unit. I'll bend those lines in and make the connection points here. That's a method. Another method is, you know, you'll run your wire through, you'll run your copper through, and you'll make a connection point maybe on your ladder. You'll make those connections, and then all you'll do is you'll lift it up, you'll hang it, and push the bottom in, snap it in, and now all your line set and everything has gone to the outside with your wiring, right? So there's a bunch of different methods. Whatever method works best for you or for that application, please feel free to do it. However works best for you. We're just giving you some options. So if you go out on the right side of this unit and push them through the wall and make your connection points outside, just remember, for service, you don't have a lot of flexibility to lift the bottom of the head up if you need to get in there for service. So a service guy would like to see the installation with the copper lines behind the unit because it does give you a little flex to hinge that indoor unit up. An installer, usually it's an easier install to go straight out the back, and that's how a lot of them get installed. And there's no right or wrong here. We're just going through the different options and different ways that it can be done. So you'll take your wiring and you'll come through. We got a little Phillips head screw in there with a black tab. The wire will go under the black tab. You'll put your Phillips head screw in, and whatever your color pattern is, you know, black, white, red, that's usually most common. Just needs to be the same. Screw 1, 2, 3, black, white, red. And then if it's a single unit, you're going to go to the outdoor unit and you're going to go black, white, red with the communication wire, which is 14-3 with the ground. Okay. If you have a multi-head system, this is where you want to make sure, you know, you keep the same pattern, black, white, red, and you're going to go indoor A to the A port and B port, C port, D port, depending on how many heads you have. So that's where we are with that. And, you know, Now you have, let's say, now we're to the point where the unit is hung on the wall. You want to add anything to that?
No, I think we pretty much covered as far as that's concerned. I just wanted to add personally, I like to personally do the method of connecting the piping and the wiring before sliding the unit through the wall. And the reason why, especially in second floor applications, when you're trying to make those connections on the outside of the building, you know, you're dealing with the weight of the copper pulling down as well. And one of the things that we stress is, you know, when we're making our fittings, you know, that it not be under stress as we're making the fitting. So that's just one of the preferences I had. But as John said, you know, there's no right or wrong way. It's whatever you're comfortable with.
Right, and even your connection method, right? We're the Connex guys, so you know it could be press fittings, flare to press. It could be you're making your own flares. That doesn't really matter to us. We just want to make sure that the flare is good and that the torque specifications are followed, so we get the proper torque on there. Remember, these are heat pumps, right? Everything we're talking about are heat pumps. We now, you know, we're dealing with, you know, units go down to -15. We're dealing with units that have the ability to cool down to -5. So we're dealing with a lot of temperature differences there. That's why torque specifications are so important. We want to make sure you have a successful install without having any leaks after a short period of time.
We had a question too. Somebody was asking about the flare tight seals. Your thoughts on that?
You know, some guys like them. Some guys don't use them at all. You know, I don't know. I'm not giving you, you know, any brand here, but if you're going to do your own flaring, as long as you got a flaring tool that'll rotate and pop when it's in, and it's good, it's clean. You know, a lot of times these things get thrown around the truck. This is a very important tool in the mini split world. It should really be taken care of, no different than your gauge cluster, right? They cost a lot of money. But here we want to make sure that it rotates and pops. This has the bevels on the head that goes in, so we get a nice roll to the flare. We want a tool that'll do a 45-degree flare. A lot of guys will use those inserts because maybe their tool isn't a 45-degree flare, and those inserts are 45-degree flares. So again, that's not a public service message for brand X flaring tool, but it is critical in the mini split world to get that flare right, because we deal with leaks on a daily basis. You know, we get phone calls, and it's a lot of it has to do with leaks. And if you have leaks, you're not having a successful install. You're not making money. And we want you guys all to make money when you're working with our products. That's why we do these webinars, right?
Yep. Yeah, so a perfect flare tool and a torque wrench, you don't need any of that stuff.
Right.
Yeah, and another question that we often get is, do we recommend using NILOG in the system? Typically, not really something that we would recommend using. We don't really actually know what's going on with the consistency of that product if it does get in the copper line sets. And being that our EEV valves are so precise, we want to make sure that we don't affect them negatively in any way, shape, or form. So if you feel like you need to use some sort of lubricant on the pipe itself, only the 410, a refrigerant oil, a little bit on the back side of the flare to prevent it from, the nut from gripping it and twisting it. That would be all that you need. But
maybe a little on the face.
Yeah, a little on the face as well.
Keep it off the threads, because that oil will throw your torque specification off. So, you're not giving this thing a bath in oil. You're just, a little bit on the face, a little bit behind the flare. So when that nut spins around, like Rob said, one of the most common things we see when we go to a job site that's leaking, when we take the flare nut off, the flare has been partially torn because when they tightened it, it rotated the copper, and that tears the flare. So just stuff that, we're seeing, just communicating it out.
Yep, absolutely.
All right, so indoor units mounted, and we got to talk about a few things there, though, right?
Yeah. So the only thing we didn't really touch upon as far as the draining of the system, if we are using it as a true gravity drain system, we want to make sure that when we're feeding the copper line through the wall, that the condensate drain is towards the bottom.
Right.
Because if we create any kind of trap on the inside just behind the unit, it's going to leak into the living environment. So keep that in mind.
That's something we don't want. So after the unit is mounted, you're probably going to, at that point, let's say it's 1 unit, 2 units, 3 units, 4 units, whatever it is. They're all mounted. Then you're going to go to the outside and start to work a lot on your outside. So let's say it's a 3-head system. So if I walk outside, currently I'm going to see, 3 holes through the side of the building. I have 3 14-3, duct seal wire, duct strip wire hanging down, and I have my line sets hanging out the outside of the building, just kind of balled up on the ground, ready to run to my outdoor unit. So it's important here, right? So if I deal with, this is the inside of my home, this is the outside of my home, in between that space I have insulation. So I just drilled a hole from the inside to the outside, and that's 2.5-inch round hole. So we always see the outside hole get sealed behind the line hide, right? That's very common. Everybody does it, whether they take a can of spray foam, whatever it is, that's sealed. Our concern is what's going on in between these joists. So we like to, talk with contractors and see how they seal it. Some guys will take, 3-inch PVC and they'll run a sleeve in between the wall. That's great. If you don't want to go to that extreme, we just get it's electrical dum-dum. You can Google it. We had a couple of conversations about it. We've Googled it, and it's just basically it's a bar of material it's a sealer. And normally what we'll do is we'll recommend that this is my inside wall again, and this is the back side of the inside hole. I take a screwdriver, long screwdriver, I put the dum-dum on the end of it, and I'll pack that around the inside hole. I want to make sure, there's a blower fan in here. I want to make sure I'm taking 100% of the air from the space inside the home and cooling it or heating it and putting it back into the home. If I don't seal that hole, and it's an old home and I got balloon construction, that means I go from the attic all the way to the basement. I could be pulling the air out of those joists. I could be getting, chemicals into that head that I don't want in that unit, whether it's insulation, whether it's particle board, you name it. There's a lot of stuff going on in between those 2 beams and the inside and outside of your home. So we want to seal that. Then if you want to use spray foam to get you to the outside of the home, that's fine. We want to make sure we're not picking up dirt and debris on that blower wheel and creating a service call 3, 5, 7 years from now and putting additional stress on that indoor blower wheel.
Yeah, and just to add something to that, so we were, myself and Jim, who's in the background over here, we're on a job with 2 floor-mounted units, and they went directly into a knee wall. The hole behind the unit was never sealed. The hole to the outdoors was sealed. However, the gentleman kept experiencing, it was, failures of the indoor coils. They kept, after a couple of years, in some cases a year, he would have to replace these indoor units. So we went out to the job site to kind of, figure out what was going on. And one of the things that we found was these holes behind the unit weren't sealed. And if you think about, construction material back in the 1950s, 1960s when this house was built, the insulation was very heavy with formaldehyde. Formaldehyde, if you're not familiar with it, is an organic acid. One of the things that we deal with on a consistent basis, especially here in the East Coast, is formicary corrosion. That's when oxygen, water, and an organic acid collect on a surface, a metal surface, and cause it to foul out over time. Since they sealed those indoor units, we haven't had to go back to that job. I think we're on 2 consecutive cooling seasons now.
Yeah, it's important, man. It's not easy to get to, I get it, but that extra step may save you a bunch of service work down the road, unwanted service work, right?
Sure.
Problem job stuff. So indoor units are mounted, we're going to seal those holes. Next, we're going to throw up the back plate, minimum of the back plate for the line hide. We want to get that up there now before we start to bend our line sets and get them in order. So it's important to understand on a multi-zone system, what does it look like? Where's my A port going? Where's my B port going? Where's my C and D port going? And when you're starting to put together in your mind how your line sets are going to line up going back to the outdoor unit. When you're dealing with this, we want to make sure the A port is the largest, and next would be the longest run. So if I have a 12,000 BTU head and 3 7,000 BTU heads, I would make sure that 12,000 BTU head goes to the A port. That's my largest head. My second unit, even though they're all the same, would go to the unit that's the furthest from the outdoor unit, the longest line set. Again, it's flare nut outdoor to flare nut indoor. We want to cover that length, whatever that is. That's going to go to the B port, then to the C port with the next one, and the D port with the next one. So largest to longest. That's how we're going to line up our A, B, C, Ds. That's how we're going to start to strategically put together, how these line sets bend nice and neat and make their way back to the outdoor unit, right?
Yeah, and basically, one of the problems, John and myself, we're both from the field. We both did a lot of these installations, and one of the issues that we came across commonly was, you pipe in your outdoor unit, and then afterwards you go to lay in your line hide, and you could run into a situation where now you have stress on the copper, trying to get everything closed, and your line hide's not going to close because you didn't run that through first. So when you put the line hide tracking in on the back, you can strap your copper line sets and drain hose into actually physically into the line hide, because a lot of them have the track built in behind them. Strap them in there nice and tight, and by the time you're ready to connect to the outdoor unit, you don't have to worry about finagling the copper to get it to connect properly.
Okay, got a question from Ray. He's asking if he doesn't put the largest capacity unit on the A port, what would happen? And what is the result?
So what happens is internally on these, right, and more, it used to be every single port had a valve, and you could hook up and isolate and so on and so on. Now, like, let's talk about a 45. A 45 has one set of valves, and basically that's it. We don't have the ability to shut off every head like we did years ago. So it's a manifold inside of the outdoor unit. So because it's a manifold, we use the compressor. The compressor is what circulates our refrigerant and moves the refrigerant in and out, right? It's like a circulator in a heating system. It moves the hot water out of the boiler and back. So here we're moving refrigerant. That becomes theoretically like a circulator out of the compressor and back. So we just want to make sure that we can get the most volume is going to go through the A port. So the bigger one on the A port, if I put that on a D port, let's say a 12,000 BTU, let's reverse that whole system. A port is the closest 7, D port is the furthest 12. That furthest 12 may have to wait for the 7s to satisfy before it gets enough refrigerant flow out there to satisfy that demand. You'll probably recognize this more in heating than you will in cooling, but I just want to make sure we're covered. So we always go largest on the A port, and it's nothing more than a resistance and flow thing, right? That's what we're dealing with here. It's a manifold. The further you get away from the compressor, the little bit less flow we're going to have, right? So that's why we do largest on A, longest on, largest to longest. That's why we do that.
Electrically too, some systems, if you put a 24, let's say, on a D port, it won't recognize it. The board will give it, I think it's a 22 compatibility error capacity.
Right.
So that's something to keep in mind.
Yeah. We just live by those. It'll save you. I'm not saying look, if you can put a system in and it's working, leave it alone.
Yeah, leave it. You don't have to go back
We're not recreating a wheel here. This is a conversation we're having and trying to, look forward. Let's focus forward. But if you have a problem job and, when you get close to that 95-degree design temperature and you're struggling cooling some of those, that's when you may want to take some target temperatures off of your, lines leaving the outdoor unit to see exactly what their temperatures are. And that's when you would go to your A port head, maybe turn that unit above temperature so it's not calling, and see if you see a change in the B, C, and D port temperatures. If you do, that could be some of your reasons of why. And also understanding your capacities, right? We are seeing a lot of systems going in because of the rebates that are sized okay, and I'll say okay for cooling. I'm sorry, okay for heating, but they're grossly oversized for cooling. We're seeing that a lot now because of the rebate structure with the 90 to 120% capacity window that you have to live within. So yes, they modulate. Yes, every head modulates on its own. Yes, the outdoor unit modulates on its own. But you need to make sure that you're still sizing these correctly so that we can dry that air in that space, so I'm not walking into a cold, clammy space because I had to oversize the indoor head so much for heating that my cooling system now is going to suffer. So keep that in the back of your mind also. We are slowly unfortunately starting to run into a lot of that, and a lot of it's rebate driven. We understand that, but that doesn't make an end user comfortable in their home, and that's our jobs, right? We make people comfortable in their space, whether it's heating or cooling. That's how we pay the bills, right? Keep people comfortable.
Yeah. And not only that, but this goes along the same lines as if we are short cycling the system, through sending the conditioned air back to the top of the unit, we're really creating the same type of situation. So anytime you see an overabundance of condensation or water on the inside of the environment, the unit's most likely short cycling due to either that the unit recycling that already treated air, or as John was saying, what was your example? I forgot. It was going with that one.
Was it too cold? Yeah, too cold. Yeah, that's fine. Also, when we're talking about line set distances here, Fujitsu has what they call an infinite comfort app. So if you're curious of what your line set minimums and line set maximums are, you can plug it right into that infinite comfort app, and that will tell you. Majority of the time when you're talking about a multi-head system, it's 16 or 17 feet, flare nut to flare nut for each head. And usually it's the furthest you can go off of any one port is 82 feet. So, just look at the book or use the Infinite Comfort app. That'll help you understand what your minimum and maximum line set distances are. They're for multi-head systems. There are minimum line set distances for the system, whether it's a 2-head, 3-head, or 4-head. And while we're talking about 2-head, 3-head, 4-head, if you're doing a 2-head off of 36 and it's 2 18,000 BTU indoor units, you have to get a kit that increases the line diameter for that system. So just little things to know and understand the nuances of what you need when you're doing these installs with all these different heads. So I think we kind of beat that to death a little bit, Rick. I don't know if there's any more questions there. But
yeah, we've got a couple of things coming in on sizing. So you mentioned size of the house, and who's asking? Ray is asking. So if you have a heat load of, it looks like 75,000, he's saying, but only 36,000 for cooling, don't you have to oversize?
Well, you have to right size. We wouldn't oversize, we would right size. I want to look at what I'm putting in the house. I want to make sure my lowest modulation numbers will fit within that 36,000, right? If I can't get down to 36,000 in cooling, let's say I stop at 42,000 BTU in cooling, but my load is 36, that's probably not a good application, right? We know we're going to overdo it in a couple of those spaces. So as long as I can look at the modulation of that indoor head, and I know if I run on low speed or dry mode for that matter, if I have to run all 4 heads in dry mode for the summer, right, which will change the dynamics of how the indoor unit works, maybe I have to do that if I'm right on the edge. But I want to make sure that I'm very close to that edge. I don't want to go too far over it because there's really no way of correcting it.
Right. Hopefully that helped you, Ray.
Yeah, exactly.
Yeah. Anthony's asking here, going back to Rob, what you mentioned about the overabundance of water and moisture. He's basically saying, the drain is flowing, unit's level, and all that coil's clean, but he's getting water spit out of the unit. So a lot of that's usually infiltration or something like that with humidity, excess humidity in the space.
Yeah, and
a couple things there.
Yeah. So another thing you could notice a funny odor coming from the equipment. These units are made of plastic, aluminum, a little bit of copper, all things that don't necessarily have their own odor. So if we are introducing an odor into the environment, that's coming from the environment that the unit is located in, whether it's coming from the outdoor unit or, maybe you have an excess amount of pets in the home that could create it as well. But most of the time that's from not sealing that outdoor holing.
and that's Anthony just mentioned, his problem, it is sealed inside and out. And typically that can just be infiltration. You get people that have kids and they're in and out of the house constantly. You know, you constantly have that high humidity in the house, cold coil, you're gonna get the spinning.
Yeah, and the amount of throw you have in front of the unit also plays into that sometimes. Or if the unit could be oversized, we're never drying that coil, right? We got a constant drip going on, and we're just unable to keep up with it. The other time you will experience that, and I'm not saying that's what's going on this job, but just to point it out, if you walk onto a job that you didn't install, check your line set sizes. If your line set sizes are not correct, that thing will rain like crazy. You will see so much moisture coming off of the line set because we're unable to control the refrigerant and have it flash off where we want it, which is in the coil. It's flashing off in the lines. So just that's outside of this conversation, but it's just something that we've experienced in the past. So
we could reach out to Anthony too, you know, on his specific issue.
Okay.
Ray's asking about dry mode. We're talking about moisture. Can you explain what that really does
Yeah,
to the system?
sure.
Does it change your pressures and stuff like that as it's running?
Right, so what dry mode will do is we're gonna try to dry this coil out, right? So just let's back that up for a minute. And the reason I said it the way I said it, right? There's cooling mode, there's heating mode, and there's dry mode. These are heat pumps. We know that all heads need to be in the same mode, right? So if it's a 4-head system and you're only having trouble with one unit, you still have to put the other 3 into dry mode. And what dry mode will do is we're just going to add a little additional refrigerant to the coil, and we're going to keep the fan speed down a little bit. We're just going to try to dry that coil out. We're going to try to dry the air out that's within that space. So we do that with a little more refrigerant and a little less fan. That's basically what dry mode does. It will shift gears to give us a different mixture. Won't change anything else within the system realistically. It's just going to take and try to dry out that coil a little bit better, reduce the amount of airflow that's going across it, so it's not seeing as much of the humidity from within the space. And we're going to try to just chill that humidity and collapse it back to moisture. We good? Good with him? Ray, hope that helped. There we go. Got some more flashing in here, guys. Good. This is excellent. This is the main reason we wanted to do this without a PowerPoint. You know, 2 of us up here instead of 1 of us. We want this to be a conversation, and we want all you guys involved in the conversation because we learn a ton when we're in the field with you. So we're just trying to share what we've learned in the field and pass it along, right?
So he's just asking, can you run 1 unit in cool and 1 in dry?
Best practice is to put them all in, because it's a mode, best practice is always to put them all in the same mode. There have been systems, you know, where I've seen guys able to do it. There's been systems where I've seen them get capacity errors. So anytime you mention mode, it's always best practice to put all heads in the same mode.
Yeah. If you guys take a look at the operation manual, it'll actually show you what modes can be run together, whether it's a fan mode
Right,
or heat
right.
mode.
Yeah,
And that'll differ across the board. So we can't make one general statement that's going to give you all of them. So that's why we're talking best practice. Look at the manual, like Rick said, or put them all in the same mode and you know, set it and forget it.
that reminds me of something that I wanted to mention earlier when we were talking about the torque settings, the torque wrench.
Yeah.
Every time you do one of these jobs, it comes with an operation and an installation manual. Inside that installation manual, you will always find our torque settings for the different sizes of copper. I wanted to mention that earlier, but lost the train of thought on that.
All right, so excellent questions. Keep them coming. We're ready to move. All right, we'll keep rolling. So basically now we've talked about the indoor side of the job. We've just talked about the outdoor side of the job. We got all these line hides now running down the side of the house. And now we're going to bring them back and we're going to figure out that outdoor unit. So a couple different things we can do here. Some guys like to, you know, build their stands, put the unit on the stand. Some guys like to hang them on the walls. If you hang them on the walls, you know, it's pretty critical. I don't know if you can see this or not, but there's a pretty good rubber mount that the unit's going to set on. That's critically important. We want to make sure that these don't vibrate. You're going to have to rubberize your connection points to the home.
There's another rubber connection down here at the bottom.
Yeah.
Especially in heat mode, when we are ramping up to 500 PSI within the system, we're going into high speed. If this is mounted right on somebody's, right outside somebody's bedroom, and it's not mounted properly, they're going to hear it and you're going to get the phone call. So HMAX came out with this pretty robust product. John's holding up the actual bushing there. You can see that's a little cutaway version. So you can see we have about, roughly 2.25 inches of rubber on the bottom of our unit that will help us isolate the unit to prevent that vibrating. Not only that, but they give us this nice little back plate as well. Okay, the level is built in, so you don't have to worry about putting a level to it. It's there. It's always going to be there. Also gives you your measurement numbers as well. The same thing with this. You want to make sure that we get this into studs on the outside of the building. Okay, so we might have to drill a couple little tiny holes, but we want to make sure that this goes into 2 studs because this is going to be supporting, upwards of 200 pounds of equipment. So that's going to be very important.
So different methods, right? Some guys want to get that outdoor unit mounted as soon as they get outside, whatever your method is. If you want to get all your line hides and line sets back to the area where the outdoor unit is going to go, then set your outdoor unit, that's fine. Gives you a little more room to work. If you're going to mount your outdoor unit the minute you get outside and then start to bring all your line hides back, that's fine. Whatever works best for that application. When we're picking that location for the outdoor unit, just remember, right? We can't have that, bushes in front of it. We need a decent amount of throw off the front side of that unit to move that air across there. We're totally reliant on the air going across the coil to either absorb heat, energy in the winter. We're pulling that across there, so that's what's really doing it for us. So you're going to get all those back, right? You're going to get your line sets back. After you cut your line sets, you're not going to be able to see this probably. I'll try to get it close to the camera, but you can see when we cut that, it's either going to push the copper out or push the copper in. If you're using the press type fittings, you're going to want to, deburr. You're going to clean this, slide your press fitting on, mark it, and press it.
Yep. Inside and outside.
Inside and out, right. We need to make sure we get proper refrigerant flow. As we get all of those back to the outdoor unit, if it's a single head system and you have not hit your minimum distances, we prefer the coil to be wrapped horizontally, right? We don't want to go vertical behind the unit. We see this quite a bit. If I go vertical behind the unit, every time I go down low, that becomes a trap in the line sets. No different than connecting inside the building. We never want to go, if I have a unit in the basement and my outdoor unit is above it, I never want to go below the unit and then come back up and connect because that makes a trap. So the connection point would be the lowest point of that system. So we don't want to build any traps into the system. We're going to get all those line sets back. We're going to figure out if it's a single or a multi. We're going to pick our A, B, C, D ports. We're going to treat the copper the right way. We're going to bend it into position. We're going to make our connections to our outdoor unit. If you have copper that's sealed on both ends, that's great. If you don't have copper that's sealed on both ends, it's never a bad idea to just take some nitrogen, blow it through that copper, try to remove as much moisture as you can before you hook it to the outdoor unit, put your pressure check and back pump on it. So what do you want to add there?
Yeah, so as far as the line set's concerned and connecting everything up, really we just want to make sure, that we're, like you said, within those clearances. A lot of times, especially with single zone systems, that are right there on the first floor, we're looking at less than the 9 or 10 feet that most of these smaller pieces of equipment need for their minimums, and a lot of times that's overlooked. And one of the main issues or main questions we get in return when we say we absolutely must have that minimum is, I don't want to make this huge loop behind the unit because it's going to look terrible. But in all actuality, we're only talking about in most of these cases one rat, and if you're using the old formula for pi 3.14 times, let's say, an 8-inch diameter, we're only talking about, we're talking about 24 feet from, 24 inches rather, from that 8-inch diameter. So, you can make it up that way. It doesn't necessarily have to be, moving the unit now 2 feet off of the wall to get a loop behind it.
Yeah, just so everybody understands where these minimums and maximums come from, the maximum comes from the capacity of the compressor.
Yep.
The ability to get refrigerant all the way out and all the way back. The minimum comes from when we go into, a cooling mode or a heating mode, especially in heating mode, when we're ramping up pressures. We need to make sure that we don't bring any liquid, I call them liquid bullets, back to the compressor, because we cannot compress liquid. Usually a telltale sign that your line set distances are too short is when you're making heat, you will hear that thing just hammering away. It will be a very loud outdoor unit. Our outdoor units never make it above 57 decibels, and we are talking probably at 57 decibels.
Yeah, so I've actually tested this. A whisper is 57 decibels roughly. Actually, a loud whisper is about 60 decibels. So, and also taking into consideration, one of the things Fujitsu is very proud of is their own compressors that they make personally. They don't fail often. And anytime I have seen a failure personally, it's been because of a line set issue, not a equipment fault issue.
Any other questions? I see a lot of typing going on.
Yeah, talking about some pressure, so I'm not going to give it away. I know we're getting there.
Yeah. Okay. All right, good. Yeah, that's great. Lead us right into the next section here, which is great. So you get all your line sets hooked up right now. What's next? So we got to go into a pressure check. And, most guys normally check pressures to that 350, 400 range because that's really the gauge cluster that they have to come off of the nitrogen tank. That regulator only gives them the ability to go up that high. So this is when I be a hard nose and I say, listen, my son's a diesel mechanic. Every time they get a new truck in the shop, he's got to buy tools to work on that truck. If you guys are out there and you're going to be working on mini splits, brand X, Y, or Z, right? This is a general mini split statement. No matter what mini split you're working on, they're going to want higher pressures. And to back that up, to understand why. In heating mode, we could be at 460, 462 PSI. If I'm testing pressure checking to 350, my operating pressure in heat is already greater than what you've pressure checked at. So cooling, maybe in that 120, 125 range, much easier. So usually a leak will show its colors going into the fall, into the winter is when usually if there's going to be a leak, that's normally when you will get that phone call, that insufficient heat phone call, because we're starting to ramp up to those higher pressures and we don't have enough refrigerant left in the system, so we're going to start to overtemp the thermistor, exiting the thermistor. So just again, another heads up as to what to look for if you're out there troubleshooting. So what we would prefer is that you have to spend a little money. You got to get the gauges that'll get you up beyond 600 PSI. I mean, that's really where we want to live. We want to get a 600 PSI test on there for about an hour, okay? During that hour time frame, this is when we normally take all of our wires and we finish our wiring, the A, B, C, D port, black, white, red, ground. This is when we will normally take and, if this pressure check is looking good, I'll do my wiring first. If the pressure check is still looking good and I'm 15, 20, 30 minutes into it, then I'll start to work on my line height and take that hour time frame that I'm doing that 600 PSI pressure check and put it, I'm going to use that time, or maybe I'm going to have my lunch during that time, whatever it is, I'm going to try to work during that time. If we prove out that we're going to meet those numbers and we're able to hold that pressure for an hour, and we're not dictating an hour to you, we're giving you a recommendation. Whatever your company policy is, that's your company policy. Don't say, hey, that bold guy at Wales Darby said this, right? Whatever your company policy is, that's what it is. This is our recommendation. This is where we see really good success rates with jobs that are tight and work for a good long time. Okay, and then after you're done with that, you're gonna take care, get rid of your nitrogen. You're gonna put your vac pump on there. You're gonna back it down, and this is where guys want to hurry up and get off the job. We got to hold under 500 microns, right? I know you pulled down under 500, and then as soon as you shut the pump off, we're bouncing back up to 800-900 microns. That's not a full vac down on that evac on that system. So
Yeah, so basically
let's
at
get it
that
down
point,
there.
yeah, we want to get it down to, close to 200. Turn it off, see where that number lands once we shut the pump off.
Everything levels out.
And if we are still above 500 microns, we want to continue that evacuation.
Clean oil in your pump. If you're doing a press system, you will not get below 200 microns. Okay, that's just again, a general statement out there. You won't get below 200 microns. Very difficult to get below 200 microns anyway, but if you have a press system, that's the number. You're not going to go below 200. If you have to turn that pump on 2 or 3 times, it will save you a ton of aggravation down the road. Again, if you're dealing with copper that has been open coil, right? We represent, Isotech UV, coated line set, keep you away from formic air corrosion. We tell all our, good contractors that we work with a lot, buy 164s because you have a lot less waste. You can put more profit in your pocket. So a 164, usually you're not going to use that all on one job. So crimp over the end. If there's some leakage, again, blow that nitrogen through that line set and to the atmosphere before you hook it to the unit. And that should cut down on your vac down time. So that's critical. Once that's done, once you've got over both of those hurdles, at that point, you're basically ready to, open valves and start the system.
Yeah.
Right?
Yeah, well, we didn't get to the point where we were running the wire, running the electric yet, but
We did.
yes.
We talked about that.
So,
Were you?
no, we talked about the
running the wires.
I'm talking about
line voltage. You're going to go to your disconnect.
Yeah, so a lot of guys have their own electrician that comes in to do all that stuff. Some guys, like to do all the electrical work on their own. But in any case, at this point, you're able to open up the valves. If the wiring has been complete, you could start the system up. But before you open the valves, it might be a little beneficial to figure out if you're going to have to add any refrigerant to the system.
Good. Glad you went there.
So
how would we figure that out? How would we know?
yeah, so you can get that information from the installation manual. You can get it online on the portal if you don't have access to the manual. But there is a specific amount of ounces per foot, and that does change from system to system. So it's not going to be one single number. In most applications, it's going to be right around 0.2 ounces per foot. So what we have to do is we have to take into consideration what the line set charge is able to carry through the copper tubing. Take that number, subtract it from how many feet of copper we have, and then multiply that by that 0.2, 0.21, whatever it's going to be, and that's going to be the amount of ounces to add to the system.
Perfect.
And we are talking about smaller numbers here. There's not going to be too many applications on the Halcyon side where we're adding pounds.
Yeah, Fujitsu seems to carry a substantial amount of refrigerant in their outdoor units compared to some of our competition. We're not adding refrigerant on a lot of jobs, but if you have to add refrigerant, like Rob said, it's going to be calculated ounces per foot. You're going to weigh that in prior to starting the unit if you can. It's better to do it prior to starting the unit and weigh that in. And what we like to do, we always like to find a part on the outdoor unit that is not removable. Because if you have multiple systems, and you put it on the removable cover, who knows if that cover is going to make it back to the right unit. So down near the compressor, there's a chrome bar that goes across. Right there, I like to have contractors write on there, port A, what head it goes to and the line set distance. And then port B, port C, port D. And then if they had to add refrigerant, that's where we would write down how much refrigerant was added to the system. This becomes a great tool for the guy that comes in after you. Okay, I can't sit here and imagine how Rob ran the line sets on a specific job where I can't see them. So that's also where that Infinite Comfort app comes into play that we talked about a little bit earlier. So that's important. So You've
So,
done all that. Go ahead.
Just wanted to briefly touch on the Infinite Comfort Pro app. It's not something that a lot of guys know too much about. Basically, what this is a great sales tool, not only a sales tool, but you can also transfer that to, let's say your salesman's not going to be on the job the day that you go out to do the installation. He already has this job saved, laid out under the job name in the app itself, and now the installation guy, the foreman on the job, or whoever is going to be doing the installation, can go to that app, to that specific job, and now he sees exactly what the salesman saw, even with them not on the job. So that's a pretty nice little feature that they have.
Yeah, great tool. Helps with setting it up. If you guys end up in an area where, there's suspect power, right? Whether it's, Jersey Shore, where we get running brownouts, seems like all the time. There's a couple of single phase monitors, whether it's an ICM 493 or AG 3000. They work pretty good. You have the ability to set the range of 186 to 253 volts, which is the exact range that the mini split lives in. And if we go below that or above that, this will shut the unit down. We recommend that you set them up for the last hit that it takes to be a hard lockout. They come from the manufacturer to take, I call it taking electrical punches. And when they take the last electrical punch they can handle, the next one will go ahead and fry the boards. So what we do is we recommend that you set the last punch up to be a hard lockout, and then you'll just replace the guts of the monitor, the phase monitor, and the outdoor system will still be intact. So
yeah, a lot
just
of times,
recommendations.
Yeah, a lot of times guys are installing the single-use ones. How you would tell if that one was actually still functioning or not is if the green light on it is still lit. So if nobody's actually sitting there babysitting the light, we don't actually know if that surge protector is protecting from a surge. It could have taken that shot already, and from that point on, it's basically just there. It just exists.
Yeah.
So the next surge could potentially fry boards. That's why we recommend the phase monitors like the ICM 493 and the AG 3000.
Any other questions, Rick? I see you typing again. We're good. All right, so let's say we have all that done. We've opened the valves. We don't have to add any refrigerant because we have enough refrigerant on board of the outdoor unit. We're going to open, whether it's 1, 2, 3, or 4 heads, we're going to open all the valves on both sides, right? Make sure we get proper refrigerant flow. Then we'll energize it. The first time you energize the unit, you will hear all of the EEV valves drive down. They're going to calibrate themselves, and then they're going to back out a little bit. So if you have a 4-head system, a 36 4-head system, you're going to hear each EEV valve drive itself closed and calibrate itself. You'll hear that 4 times in a row. After that, it's going to be the longest 2 minutes and 20 seconds of your life, because you're going to think you did something wrong because the outdoor unit did not come on. During that 2 minutes and 20 seconds, usually the indoor heads will come on. They'll start to circulate air. While they're circulating air, the air thermistor is collecting data and sending it to the outdoor unit, and the outdoor unit is starting to digest that information. And at 2 minute and 20 second mark, the outdoor fan will come on and the outdoor unit will start to function. And based on all of the feedback it's getting from each one of the indoor heads, the outdoor unit will figure out where it needs to run and operate in order to support the demand of inside the home. And we will start out at a low frequency, like a frequency of 80 on the outdoor unit, and then it will stage itself, ramp up until we get to a point where we're going to marry up to what the indoor system is calling for. All right, on the initial demand, the outdoor unit actually has the ability to go beyond its normal capacity to support that indoor demand, and then it'll reel itself back in and start to modulate, 100% modulation on the outdoor, 100% modulation on all of the indoor heads. So that is the system operation, and you guys just did an awesome install. So hopefully the home is now in cooling mode or heating mode, and you're up and running, and you got a good tight system, good clean system, and you're good to go.
Yeah. And I just want to add to, if you guys have any questions at any point in time, We have a solid group of guys here, John, myself, Rick Coster, Jim DePalma, and Anthony Tassi. We're always here to answer questions. We're always readily available. So, please feel free to reach out to us if you have any questions, concerns, issues, or anything along those lines.
Any live questions going that we jump into? Anybody have any questions out there you want to fire in? We left some time at the end here to answer questions and just, again, carry a conversation.
Yeah, just want to give everybody heads up too. There are some handouts today too. Full line catalog where you'll find a lot of line set dimensions, capacities, combinations, stuff like that. So don't forget to download them.
Yeah, that's the new 2022 version. So that's got everything, all the new equipment that's out now.
Yeah, that's a good one right there, Rob. I'm glad you brought that up. Very important to really take a look at the catalog. There's a ton of new model numbers. Most everything is backwards compatible, but there is a ton of new model numbers. There's some new capabilities on these new model numbers. And probably the most important one is any of those units that have gone to a 2-wire are sold a la carte. You have to purchase the wall controller separately. Okay, if you do a wall unit like this, it's going to come with the remote. That hasn't changed. But majority of everything else is switching over to a 2-wire system for your wall controller. So you have to purchase that wall controller separate. I don't want you to get to a job site and realize it, 4 o'clock in the afternoon, you don't have a wall controller.
John, can you repeat how to use and what you call the sealant for the indoor?
Okay, so yeah.
The electrical dum-dum.
These guys have been busting my chops all week about this, but it's called electrical dum-dum. It comes in like a little gray block, brick-looking thing. And it's real pliable. Electricians use it to put around the like a seal tight, around the wire like a seal tight. Me personally, I've used that I put my first mini split in 1984. Okay, old Sanyo system for the old owner of the company I used to work for. So I've been using that stuff since then, and he's the one that taught me to do it that way. So Google dum-dum, electrical dum-dum, because Jim Googled it. Stevie was here yesterday. He Googled it. Nobody believed me with I think that's my nickname for it. There are a couple other nicknames for it. Other guys call it different things, which I can't say here. But it actually works really well and it's very pliable.
Ray had a great question too. He wants to know which condensate pumps we prefer.
That's going to be dictated by the application, but you probably can't see this well. I know I'm out of screen. All you have is my hand
You
now.
have one right around the corner.
This is a freezy. This is a freezy. This goes mounts directly to the unit.
Right around this corner.
Wires directly to the unit, and that's a real neat. It can go on either side. So that's a real good one. We have about 4 different condensate pumps that we represent under the HMAX name. Good success with them. We got a magnet contactor in there. It's condensate pump needs to be serviced, but they are very robust. We have I think there's one job site Rick you did with like 300 of them on there, right? And we've had good success with them.
Got some good stuff out there. HMAX.com so you can find all of that.
What else we got?
Ask about some recording. So we do record this. You will have access to it on our website. So that's not a problem, Chris, and that's about it.
Yeah, and one thing I did want to mention about the electrical dum-dum as well. If you don't have access to it from the outside, if you can't get to fill the inner hole from the outside, you can actually remove the cover of this unit. This pops up. You have 1, 2, a third screw behind the electrical panel, 3 underneath, and this will pop right off. It'll give you access to that whole area underneath on either side where you can do what you have to do.
Yep. It's easier from the outside, but that's a good method if need be, for sure. That's what we got for you this morning. We appreciate everybody for pitching in here and helping out and asking the questions. That's we're really relying on that. Our new series of training that we're doing, 50% of them are going to be more like this, where we're carrying a conversation hands-on. We have some hands-on stuff coming in a few weeks. So next week we're doing water conditioning, and we're hopefully waiting on a valve, but we might be able to do a disassembly of a valve so everybody can see how a valve comes apart. We're changing the game again in training, and we want to be in the forefront. So we're racking our brains. We're working hard at it. We appreciate everybody signing up and participating with us and asking the questions, because really this is for you guys. We don't want to sit here and dictate information to you. We want to make sure we're delivering information that you're looking for. So it's really important for you guys to pitch in, make sure we're going down the right road. If you're unhappy with what we're doing, please email us. We want to get and be as good as we can be. And again, we don't want to dictate information to you. We want to work with you and understand what your needs are so we can support those needs. And we will change up anything we have to change up. We have 2 live studios now, a ton of equipment. Hopefully you're going to see, we're keep raising the game here in this webinar world, because this is difficult to do live webinars. We're used to being in front of you guys, which we are in front of contractors now. So if you have a facility, you need us to come to your place, please reach out. We'll figure out a way to make that happen. If we have to bring equipment with us, we can figure out a way to make that happen. So again, we're trying to do this to the highest level possible, and we want to make sure we're hitting the marks. So we appreciate everybody's participation. Everybody in the room, thank you. And we will see you guys next week.
We got to, just real quick, Rob, can you give Ray some tips on how to get the cover off without breaking the bottom?
So the easiest way, so are we talking about on the bottom of the unit itself?
Yeah, off the bracket.
Yeah, so the easiest way to do that is to actually pull the front cover off so you can see what's going on underneath. Once
the bottom clips and the top clips are difficult. So if you get one of those screwdrivers with the 90-degree bend on them, you can usually reach in behind it, pull down on it, pull out. That'll get you off the bottom clips. On the top, the mechanism on the top, guys break those off quite a bit. The mechanism on the top is you have a little link like this, and the other one comes in like this. So you're going to reach into the vents right here, and you're going to lift up on that. And that's going to lift this up out of that little notch that it's in, and then you're going to pull the cover out. So we see a lot of destruction that takes place, more on the top than the bottom. But yeah, one of those offset screwdrivers with the hook on it, go up underneath the back, pull down on it. As you're pulling down on it, just pull the cover out a little bit, go over to the other side, do the same thing. That'll get the bottom off. Then when you go to the top, you're going to go in there usually with a screwdriver, nice and gentle, and you're going to lift it up and pull out at the same time. That'll get you out of that little hook.
Yeah. And if you have to apply any kind of force to the top of the unit, stop, because you're not doing it right.
Yeah, you're going to break something.
Yeah,
Absolutely. Absolutely.
So hopefully that helped.
Yeah. So Ricardo's asking, he's got applications that require makeup air, and how can he do that? We can do that with other manufacturers.
Yeah,
absolutely.
Yeah. Electro has a nice makeup air system. That'll be third party. The only real one you can introduce is if you have the large ceiling cassettes, we can bring some outside fresh air into that, and you just have to realize how much fresh air you're bringing in so you size that system properly.
Exactly.
Usually by others is just easier because your makeup air system is going to take care of the BTU loss and the BTU gain that's needed.
Joseph's asking if we visit tech schools, and absolutely.
Absolutely.
100%. Yeah, we tech schools all the time.
Yep.
Joseph, we'll reach out. One of us will reach out to you and find out who you are.
Yeah, send us an email, Joe, and let us know what you're looking for. Doesn't just have to be Fujitsu. Could be hydronics. Could be a whole bunch. Yeah, Rob's actually going to one on Friday. So
the big one.
Yeah.
65
kids. So we do that. We do adult education in the evenings. Whatever we do, the tech schools all throughout the day. Whatever you guys need, let us know. We want to be the go-to people.
Yeah, and specifically, so we were talking about the webinar series. Rick's going to be doing one specifically on Fujitsu troubleshooting coming up. So that's going to be 2 weeks from today, right?
28th,
yeah, the 28th, same time, same place.
Same scenario.
Yep.
We're going to try to do these. Like I said, more than 50%, I think, are going to be like this, live, no death by PowerPoint.
Exactly.
We're just trying to elevate it, man. That's all. We're just trying. All right, we're good. Thank you very much. Appreciate everybody.
Yep, thank you for all your time and joining us today. We truly appreciate it.
Have a good day.